This is Pre-Algebra Lesson 8-8, Graphing Linear Inequalities, Part 1. A linear inequality is a number sentence in which the equal sign has been replaced with a greater than, less than, greater than or equal to, or less than or equal to symbol. The graph of a linear inequality is a region of the coordinate plane bounded by a line. Every point in the region is a solution of the inequality. This is shown by shading your inequality. The only real difference between graphing linear inequalities and linear equations is the boundary line. In an equation, the line is always solid. In an inequality, the boundary line is solid if it's greater than or equal to or less than or equal to. The boundary line is dashed if the inequality is greater than or less than. I kind of liken it to playing sports. When you play soccer, the boundary line is not really out of bounds until the ball has crossed that boundary line by over half. So in actuality, the out of bounds line is in play until the ball is more than halfway across that boundary line. However, in volleyball, when the ball lands on the line is out. It doesn't matter if half the ball is across the line or part of the ball is across the line. Once the ball touches that line, it is out. That's the difference between the two boundary lines. The soccer boundary line, that boundary line is actually in bounds, and you can be out of bounds playing that ball, as long as the ball hasn't crossed more than halfway across that line. So, if we're going to determine whether or not we have a solid or a dashed line, we simply just need to look at the inequality symbol. Okay? This is the easiest way to remember it, and I tell my students this all the time. If the inequality symbol is greater than or equal to or less than or equal to, it is a solid line. If it's greater than or less than, it is a dashed line. Simple as that. So if we look at this first equation, y is greater than 5x, it's a greater than. It doesn't have the equal to symbol, which means the line is not in bounds. The line is not part of the solution. Therefore, this would be a dashed line. In equation 2 here, we have y is greater than or equal to 7x plus 12. It has the equal to symbol right here. Therefore, it will be a solid line. Number 3, y is less than negative x minus 1. Since that inequality symbol does not have the equal to sign, this is a dashed line. Simple as that. You just need to remember to make your lines dashed or solid. Steps to graphing linear inequalities. They graph very similarly to linear equations. Graph the boundary line. In other words, graph the equation with the proper dashed or solid line. Once you have done that, you're going to test a point that is not on the boundary line. 0, 0 is always a good point to use, as long as the boundary line does not go through the origin. If the test point makes the inequality true, you shade where that test point would lie. If the test point does not make that inequality true, you shade on the other side of the line. And that'll make more sense when I go through the example. And be sure to label all your graphs. Let's take a look at graphing some inequalities here. And we're going to graph the first inequality we're going to graph is y is greater than or equal to 3x minus 1. First thing I like to do, I like to tell myself, solid line. So my brain knows I need to make this a solid line. This is in y equals form, which is really nice. So we can use slope-intercept to graph this. My slope is 3, and my y-intercept is negative 1. So I'm going to cross my y-axis at negative 1. My slope is up 3 over 1, up 3 over 1. My boundary line is solid, so I'm going to draw a solid line, just like I would do normally. Okay, so far we haven't changed this from what we've been doing with linear equations. We've basically done the exact same thing that we've done with linear equations here. Then I'm going to label my line. My arrowhead's on the line, and I'm going to label this. And I'm just going to call it equation 1 because it's easier. Now it comes to the part where we have to shade, because our solution will be either on the right side of the boundary line or it'll be on the left side of the boundary line, because that's what inequalities are. The inequalities are many solutions. Therefore, we don't want to have to name all the solutions, so we shade the graph to tell people what the solutions are. The easiest point to test is 0, 0, provided your graph does not go through 0, 0. My graph does not go through 0, 0, so I'm going to test the point 0, 0. And here's how you test your point. I'm going to test 0, 0. I'm going to put 0, 0 into my original equation, in the equation of y is greater than or equal to 3x minus 1. X x is 0 and y is 0. So y becomes 0 is greater than or equal to 3 times 0 is 0 minus 1. 0 is greater than or equal to negative 1. That is a true statement. 0 is indeed greater than negative 1. So I am going to shade where 0, 0 lies on my graph. Okay? 0, 0 is right here, so I'm going to shade on this side of my graph. So I'm just going to take my graph, and I'm going to shade. And I would suggest you don't shade so dang dark that you can't see your line. I get people who take their pencils and shade so dark you can't tell if their line is dashed or solid. If you want to shade in a colored pencil, that is fine. Do not shade in ink because you can't erase it in case you make a mistake. That would be bad. So as you can clearly see, the only difference between graphing an equation and an inequality is the fact that your inequality will have either a solid or a dashed line, and it has to be shaded. Other than that, it graphs just like an equation does. Let's take a look at the second one over here. Y is greater than negative x plus 3. I'm looking at this and going, greater than, have to have a dashed line. It's the first thing my brain sees, must have a dashed line. Okay, my slope is negative 1, my y-intercept is 3. So I'm going to cross my y-axis at 3, my slope is down 1 over 1, down 1 over 1, down 1 over 1. I need a dashed line. Lucky for me, I can get dashed lines. I need a dashed line here, so I'm going to just draw a dashed line. Okay, so we're going to just a little bit. There we have it. My lovely dashed line. Put my arrowheads on the end of it. This one already has them, but I'm doing it anyway. This is equation 1, so I'm going to label it with equation 1. Now I need to test to see if I need to shade to the right side or to the left side, or what some people might say above or below my dashed line. So I'm going to test the point 0, 0. Okay? Because it doesn't go through 0, 0. If it does go through 0, 0, pick a point that is clearly, definitively on one side of the line or the other. Preferably one that has a 0 in it, because it makes it a little easier. So in the equation of y is greater than negative x plus 3, I'm going to put in a 0 for x and a 0 for y. So I get 0 is greater than 3. That is a false statement. 0 is not greater than 3. So I am not going to shade where 0, 0 is. Do not shade where 0, 0 is. Ooh, a little bit here. So I clearly must not shade where 0, 0 is. So here I am. I'm going to pick my lovely color here. So I'm going to shade up here because this is not where 0, 0 is. 0, 0 is down on the other side, so I'm going to shade where 0, 0 is not. And notice I don't get so close to my dashed line that I can't read my dashed line. I have the option of doing colors. I would suggest if you want to make it nice and neat, you can use colored pencil. Do not use ink. Remember what I said. You can't erase ink. It makes it really messy, especially if you make a mistake. Okay, so let's take a look at another example. If it's not in y equals form, you have to put it in y equals form. Okay, so no different than before. We have this lovely equation here. And I already know it's going to be a solid line because I can see the equal to sign right there. So I now have, I'm just going to rewrite this over here, negative 2x plus y is less than or equal to 4. So I need to add 2x to both sides. So I get y is less than or equal to 2x plus 4. Okay, so now I can graph this. My slope is 2, my y-intercept is 4. So I go up 4. My slope is up to right 1 or down to left 1. Up and to the right is the same as down and to the left. And exactly the same thing. Up right is the same as down and left. And you'll learn that very quickly if you haven't already learned it. The solid line, so I can graph my solid line here. I kind of missed, so I'm going to straighten that out a little bit. There we go. Got a little place for me. Put my arrowheads on it. If I label this equation 1, I can label this equation 1. It doesn't go through the origin, so I can test that. I can test the origin. In the equation of y is less than or equal to 2x plus 4, I'll put in a 0 for x and a 0 for y. Is 0 less than 4? 0 less than or equal to 4? That's true. 0 is definitely less than 4, so I can shade where 0, 0 is. So I'm going to shade where the 0, 0 point is. Means I'm going to go in this entire section here. Shade that in nice and neatly, or so somewhat neatly, so people can tell where my solution is. As you can see, it's not really hard to graph an inequality. Just need to make sure you use the proper gas or solid line, and make sure you shade it. You can solve real-world problems using inequalities. Okay? And it doesn't necessarily have to be graphed to solve it. It says cashews cost $2 a pound, pecans cost $4 a pound. You plan to spend no more than $20. Write an inequality to represent the number of pounds of each that you can buy. All we're doing is writing an inequality. We're not solving it, we're just writing an inequality. Okay? So I have pecans and cashews. I'm going to let X equal pounds of pecans, and I'm going to let Y equal pounds of cashews. And by the way, that's the symbol for pound. It was the symbol for pound long before it was a hashtag symbol. Okay. So, if cashews cost $2 a pound and pecans cost $4 a pound, and I can't spend more than $20 because that's all I have, the cost of my cashews plus the cost of my pecans has to be less than, has to be less than $20. Okay, my pecans cost $4 a pound. So 4x plus my cashews cost $2 a pound, 2y has got to be less than, no more than, I can go up to it, less than or equal to $20. I can go up to $20, but I cannot exceed $20. So 4x plus 2y is less than or equal to 20. If you interchanged your x and y, you could have 2x plus 4y. It doesn't matter as long as you have these labeled as to what they are. And that's an inequality that we could graph if we needed to, but we don't need to. So you can solve equations by writing linear inequalities. And that's a linear inequality for that particular word problem.